So here's a tutorial on how to do the hydrate problems from your worksheet, AP2 combustion hydrate ... I do have a short 2-minute video to explain what a hydrate is with pretty pictures. But let's look at our hydrate here. This is copper chloride and is attached to water. That's what makes it a hydrate. This is attached through intermolecular forces, hydrogen bonding, okay, and that is physical bonding, not chemical bonding, as you might see in some other websites. Okay, so what we have here is we have so many waters. I don't know how many are attached to so many copper chlorides. Okay, in your worksheet it tells you to find X. That's because this is going to be 1 in all these problems, but it doesn't have to be. Okay, this could be a 2 to 3 ratio. And what are we doing? Well, it's exactly the same if I was looking at copper chloride. I have 1 mole of copper to 2 moles of chloride, okay? But here we're looking at whole compounds. So I have so many moles of copper chloride bound to so many moles of water. So we are, again, finding our mole ratio, and it's our chart that we did, percent to grams, grams to moles, divide by lowest, then make whole, okay? But instead of using our elements, we're finding the mole ratio of whole compounds, water being the part that's hydrating it. So we have this formula, and this is how you write it with a little dot. And what they gave us was the total mass for this hydrate is being 2.235 grams. And then they told us the mass of the copper after we got rid of the water. How did we get rid of the water? Well, we just put this in a crucible and heated it up and drove off all the water. And the mass of that is 0.185. So hopefully we'll get in here and we'll do this lab, because there's some lab techniques going on here. How do we know all the water's driven off when we heat it? Well, we weigh the crucible of the copper chloride, and then we heat it again and we weigh it a second time. If the mass is identical, that means all the water's gone. If the mass is still going down, then we need to keep heating until that mass levels off, and that is some lab technique for you. So back to our problem. We have the mass of the compound minus the copper chloride that they gave us. That's going to leave us with the mass of the water. So I just plug this here into my handy dandy empirical formula chart, and I convert it to, okay, and then we divide by the lowest, and I get a ratio of 1 to 2.01. That is a perfectly reasonable rounding to 2. Okay, and then we have copper chloride 1 and 2 water, so copper chloride dihydrate. So something else we can use this for, and remember, they're using all of this years and years ago to decide what these subscripts were or what these coefficients were, and this is how they found out how molecules went together, and they started putting together the idea of how these atoms were and what was happening through the bonding. So let's look at this. We got calcium oxide in water. Now I know that oxides with water make hydroxides and that it's a synthesis reaction, but they didn't know that. There were double replacements, and we have a hydrogen bonded to a hydroxide to make water. So how do we know this wasn't a double replacement and there wasn't any hydrogen left? Well, they could find out the mass of the calcium plus the mass of the water, and they can make sure the mass coming out was identical, and that would be law of conservation of mass. I can also find those subscripts here and make sure that this balanced properly. If there was hydrogen coming off, there would be another product here and it wouldn't balance properly. So that's just another way that they used this analysis to determine a lot of different things that they didn't know way back when. So I hope that helps.